today we're going to be talking about this new package, dbt-ml-preprocessing. Wanted to open just with a few recent quotes. They're actually all from the same podcast from late last year, A16Z, essentially highlighting that there's really no need for the tools separation that we see between the BI world and the data science world. This really matches my thinking. And so listen to the episode to see that conversation in full. Quick bit about me. My main background is as a software engineer and a systems architect and integrator. About 5 or 6 years ago, I switched to working primarily with data science teams and really enjoyed just getting to know how they work, what they do, how they approach things. I'm a big fan of open source. At previous companies that I've worked at, we've used a lot of the tools in the modern data stack. So I've used Snowflake, dbt, and Fivetran as a customer. I'm now the CEO of Omnata, which is, as Claire said, an Australian-based startup that I co-founded last year. We're building native integration between data warehouses and cloud apps. So my talk today centers around our recently released dbt package. It's essentially a SQL port of Python's scikit-learn module. And it's actually based on a Medium article that I wrote a couple of years ago, back before I knew about dbt. It runs on Snowflake, BigQuery, and Redshift, and it could probably run on others. Over the course of this talk, you'll see what the tool does and why you should use it. And you'll also see why at Omnata we decided to sponsor it as an open source offering, just where it aligns with our vision as a company. We really want people to be able to manage more workloads within their data warehouse. So the example project for this demo is also in GitHub. I'll post a link to it just afterwards in the chat. That'll just let me move fairly quickly. I've sort of got limited time, so people can dive in a bit deeper offline and actually look, line by line through the code and ask questions in the Slack channel. In the interest of time, this is sort of like a semi-live demo. I've cheated and pre-ran a lot of the code, but I've got all the logs for proof, so don't worry. Just starting with the uncontroversial. So this slide shows, I think, a typical workflow for a data scientist. It doesn't say where these tasks should be performed. It's just really the flow of a data science project. And, recently there's been a lot of chess pieces being moved around by different vendors as to where these tasks are performed. So you've got Databricks traditionally on the model building end, kind of branching out into data warehousing. You've got Snowflake kind of doing the inverse to that. You've got ML platform vendors like H2O and Data Robot encouraging more to be done in the data warehouse as well. And then, of course, Google, Amazon, and Microsoft are really sort of consolidating and grouping these features under sort of unified product banners. So there's a bit of jostling for these different tasks. And I think for this audience, where we see the combining of different data sources and transformation is where we're typically already using dbt. And then the rest of the feature engineering is run either on Python or Spark or Scala outside of the database. So as part of this talk, we're going to be giving dbt the job of managing feature engineering in its entirety. And then for the training parts, I'm going to use Amazon Sagemaker. So this is our source data set. It's a classic bank churn data set, describes customers of a bank and whether or not their situation has resulted in them leaving in the following 6 months. The way that the problem's been solved, like the choice of algorithm and feature engineering, originally comes from a super data science course online. But I do find with a lot of these sample machine learning data sets that they come fairly generously pre-processed already. So there's a whole lot of feature extraction that happens, like you have, thanks Claire, you don't generally just throw raw data in from your data warehouse. You're usually drawing out information from just beneath the surface. So for example, the age field is going to be derived from the date of birth. The number of products is going to be like an aggregation of a product membership table. The has credit card flag is going to depend on the types of products held. And you can really take that as far as you like. You could turn an address into the distance in miles from the nearest store or the population of that area. So in my example project, I've put in a bit of effort to actually work backwards and generate what I think are more realistic real world starting points. So hopefully you see a machine learning pipeline that kind of resembles operational reality. And then from there, we're mainly looking at what to do with missing data and also actually get into this package, which is where we encode the data to suit the machine learning algorithm. So the solution from Super Data Science is a artificial neural network. And so we're going to be using a one-hot encoder to encode the geography and gender columns. And then for all the remaining numeric values, we actually have to scale them because neural networks exploit distances or similarities between data samples. So they actually need all of the numeric fields to be on the same scale to work effectively. So that's why we've chosen these two methods. I said before that this part is often done outside the data warehouse. So what's wrong with it doing it that way? I think some of the academic arguments against that is that the reuse of features tends not to occur naturally. They tend to end up in a single ML pipeline. People don't reuse things unless they're in a reusable place. Doing it at scale is trickier. You've got change management challenges with notebooks, and then or any of the complexity that comes with moving data in and out of the warehouse. But there's also a human element to it that I've over the years developed fairly strong views about, and that is that it's a totally unnecessary demand to place on a data scientist. So just to unpack that a little bit, this is a popular diagram. It's not perfect, but it's a useful grouping of sort of the common skill sets that you see. I really believe that it's the job of an analyst or a data scientist to really stay focused on the problem that they're solving, which is the business context, the statistical properties of the data, what they're trying to predict, and what techniques they can use. And I think we sometimes, when we find ourselves with a new computational challenge, it's usually the data science camp whose job it is to sort of forge ahead. But I think we have a bit of a checkered past as to what we expect from people who want to use a computer to solve these tasks, and we sometimes drag them into the how, which is a really big context switch from what they're meant to be doing. And certainly there was a time when if you wanted to sum a billion numbers, we said, well, you need to learn Java, you need to spin up a Hadoop cluster, manage that, you need to embrace this MapReduce paradigm, you need to learn how to write efficient MapReduce jobs, and you're not willing to skill up in all those areas, you need to hire these rockstar developers to help you sum those numbers together. So I think we allowed an unreasonable technical barrier to exist between an analyst or a data scientist and the answer to their fairly simple question. Of course, at Facebook, they rejected that idea, and I like to imagine the analysts revolted and they got their common sense solution back, which is SQL. And I think there's a place for tools like Spark and Hadoop, but just not for standard kind of tabular analysis. And the reason for this little rant is I think there's a bit of a new wave of this at the moment. I don't think there's anything wrong with knowing Python or R. That's a reasonable skill set to have. But in reality, that's usually not enough, especially for production. So aside from having to learn the nuances of each machine learning library, you really have to know infrastructure. You're going to be reading and writing to object storage. You've got to use the right file formats, encryption techniques, storing credentials securely. And what starts out innocently as data science quickly becomes mostly about software engineering and cloud DevOps. So one of the big motivations for me to port scikit-learn to SQL is simply just because I love SQL. It's been stable over the years. It's a good amount of abstraction for the task, and it makes pre-processing about the what, not the how, and you don't have to deal with all these infrastructure concerns. So with that out of the way, let's get into our example project. This is a typical Sagemaker ML pipeline, which to cover the risk that I make this look harder than it actually is, I've actually just used canonical examples from the Sagemaker repo. So the gist of it is our cybernetic data scientist uses a Jupyter notebook to drive these Sagemaker tasks, and the data gets bounced in and out of S3 at each step. So you pre-process your data with a scikit-learn container, you train off it using a TensorFlow container, and then you store the model back into S3. And then you can deploy an endpoint, which is pretty cool. Sagemaker will manage that for you. But I want to just show you what these scripts look like that you have to write. This is a small snippet of the scikit-learn script. It's 177 lines long. And if you look at what it's actually doing, if you take out the white space in the comments, it's mostly dealing with either just Python related stuff like packages being imported, and then a huge chunk of it is just file format related, like parsing CSVs and handling data channels out to the next part of the pipeline. And actually only 5 lines of that 177 are actually saying which encoders we want to apply to which column. And I mean, thankfully, the TensorFlow script that controls the training is a bit shorter. It's only 61 lines of code. And a good 20% of that is dedicated to, what our neural network should look like, how many inputs, how many layers, and all the other parameters. And only about half of the script is it carrying its own weight as a Python script. So that's good news, because this is the script that we're actually going to keep. So now the first thing Sagemaker is going to see under our new architecture is we're going to move all the pre-processing out into Snowflake, and it's going to be managed by dbt. And then we pass that pre-processed data directly into the training container. So this obviously limits us to batch scoring, which I think is usually okay. However, the good trade-off is that we can do away with a lot of Python scripts and stop worrying about file format wrangling. And we have a reusable feature store in the database, so we can use this in other projects. So I'm just going to talk through the actual project here. So this is what the docs look like. I mentioned before that I generated these raw tables as a more realistic starting point. So if I look at that, this is the customer transactions table, and there's 4 other tables that have all the information we need. So the first thing we're actually doing is using a snapshot of the customer state. So what that looks like is we're pulling together all the raw data, and we're outputting something that resembles that canonical bank churn dataset, except it's derived from more basic sources. The reason we do it as a snapshot, I'll just show you. So we're going to zoom in and go down the training path first of all. So this is generating a training data set that we can pass to Sagemaker. Typically, a data scientist will come up with some kind of time traveling SQL query. And so they'll be having to look at what state the customers were in some time ago and compare it to today. So because we have this snapshot occurring over time, we can look at putting together this training data set is as simple as what was the state of the customer 6 months ago using the dbt valid from and to standard columns, and we join it to the state the customer's in today, and then we have a nice training set ready to go, and we can use that same snapshot for scoring ongoing. So once we've done that, we're just going to sort of follow this training path all the way down. We're going to impute the empty balances. We're going to just replace with the median value. And here's where we finally get into our new library, which is where we do the pre-processing. So we're using, hopefully you can read that, we've got the one-hot encoder encoding the geography and the gender columns, and then the standard scaler is scaling all these numeric columns, and then we're pulling it all together here into this model. So what that looks like afterwards is, whoops, not that one. Here is our pre-processed data set. And that looks exactly, these numbers are identical to what you would get out of scikit-learn if you did the same operation. So then we can go over to Sagemaker, and I won't go too close through this notebook, but we essentially grab our Snowflake credentials, query that table I just showed you, split it up into test and train, and pass it into the TensorFlow container. Then we do a whole bunch of training and waiting. And then at the end, it tells us 84% accuracy for that model, and then we deploy it to a Sagemaker model endpoint. So that's cool. We've got our feature store here. We've got our training mechanism. Now, I really want to spend, we've got almost 10 minutes left. I want to spend a fair bit of time talking about sort of the day-to-day reality of this pipeline. So what happens, on day 2 and day 3 and so on. So what do we do with this churn score once we have it? This is a huge emerging area. And I just want to consider, first of all, the advantages that we've won ourselves by running the show out of dbt. I think there's a lot of talk about real-time analytics, but I would say don't overlook the power of building a batch pipeline that works completely incrementally, because that's the key to having micro batches that can run more frequently and more efficiently. And in the case of our churn prediction, we're measuring things like how many products a customer has, how long they've been a customer, their age, things that change very occasionally. And they're the only ones that we actually want to see coming through our pipeline. And that's the ones that we want to rescore and push onto their operational systems. It's probably no surprise to a lot of people on this call that you can do the inferencing from within the data warehouse now. Both Snowflake and Redshift have published articles on how to do this using their external functions to call out to Sagemaker and get the churn score back. So I've built that into this project, and you'll be able to see that in the repo as well. I've just kind of adapted one of the Snowflake examples. And then to demonstrate the consumption part, I'm going to use Salesforce in conjunction with our 2 products. So Omnata Push is our ETL that runs natively out of Snowflake and Redshift. It's really for basic scenarios. For example, pushing a churn score into a contact. And then the other consumption model, which is live access to the warehouse. And that's because a lot of the time you don't want to lose that detail. So I'll show you in a minute that we're actually going to snapshot not just the source tables, but we're going to snapshot the predictions history as well. Because even though you should use snapshots sparingly, this is an example where we're actually generating data within our dbt pipeline. So it makes sense to store a history of it as needed. So because of the way we've set this up, we can make all this a reality. We have our snapshots, the models that serve as inputs, I should say the dbt models that serve as inputs to our machine learning predictions are all incremental models in dbt. And then we have the predictions running incrementally off that. And then the loading off into Salesforce is also incremental. So we end up taking the bare minimum number of customers through that pipeline. So let me just show you, we're going to go down the scoring path or the inferencing path. So I've pre-ran all these commands just in the interest of time. So this was from the training part. We snapshot the customers. We run all of the models down the training path. We've already done this. So you can see when we run the models from the inferencing path, originally, the first time we ran this, we had about almost 8,000 customers go through the pipeline. And you can see them move through the imputing and pre-processing steps and then being loaded eventually into Salesforce. What I wanted to show you was what happens when something changes. So I've taken a snapshot of what the predictions were from the first run. And then what I did was give a couple of people a salary deduction. So I gave one person a pay cut of 1 cent and another person a pay cut of quite a lot. So what I wanted to see was, the churn score for one is going to be a negligible change, and the churn score for the other is going to be significant enough that it's a new one. And then all the other customers haven't changed at all. So I ran that script at this point, and then I reran the snapshot for the customers. And when we do the actual inferencing part, all we're doing is we're grabbing the customer state snapshot for all the customers who are current, and we are looking at the snapshot state to determine which ones we actually need to consider in this dbt run. And then similarly, imputing steps and pre-processing steps, we're also supporting an incremental build. And then if we actually follow this through, you can see that we saw 2 customers change their current state. And we can see just those 2 customers working their way through the pipeline. And you can see these all run fairly quickly in a matter of a few seconds. And then we're going to rescore those customers and load them in. And finally, we take another snapshot. So what that ends up looking like, so we have our data loads pushing out into Salesforce. That's also incremental. So if I look at the 2 people that we gave a pay decrease to, I can't remember which was which, but one of them, you can see if we look at the prediction history, so this is looking back at the full table of churn predictions. This is the person that got the 1 cent pay deduction, and so they still only have 1 churn score. Whereas if we look at the other, we should hopefully see, yeah, we see 2 predictions because we see the salary was massively reduced, unfortunately for that person. So their raw churn score actually changed. So that's the full pipeline. As I said, I'm gonna tidy this up and I'll upload it. I'll post the link in the Slack channel afterwards. So just to recap, I would say, by all means, learn Python and R. I'm happy for people that can learn a lot of different skills like that. But I think if you're good with numbers and analysis, but you're not naturally interested or gifted at software engineering, that you shouldn't actually feel bad about that. They are very different skill sets and not necessarily complementary. And I would also say, based on what I've been able to demo, that you can not only build an ML pipeline in dbt, but you can build a really good one. And using a lot of the building blocks that dbt provides, like snapshots and incremental models, are actually really useful to simplify ML pipelines and actually avoid a lot of the big challenges that happen when you do this outside of the data warehouse. And also don't forget to operationalize it, because if you don't do that, it's all for waste. So that's it. One ask that I do have, if anyone does want to try out the package, I'd really love to hear about your experience with it, good or bad. You can find me on the dbt Slack or on LinkedIn. Already got my first pull request from somebody that wasn't me, which is really cool. So hopefully other people can get some value out of that package as well. Anyway, that's time.
James, right on time. Incredible. Thank you so much for that presentation. I'm just so excited to see sort of these data science and analytics workflows come closer together. If anyone's seen our pretty classic product chart where we talk about data loaders, warehouses, raw data, transform data, dbt sits in the middle. We always talk about BI tools, and then we have this arrow to data science workflows, and that's sort of as much as we say about it. So this and a few other things going on in the community is really exciting to see, to prove that these 2 workflows can coexist in a really nice way. So yeah, thanks for working on the package and also sharing what your work with us here today. Cool. So Claus.
Thank you. That was super cool, James. Thank you. I've been waiting for this for a while, when you first started writing the blog post and then the package. And so kind of along the lines, I think maybe the package I'm talking about goes a little bit in that same direction. Excellent. So I'm going to talk about a package. I'm hoping you guys can see this presentation here. So talking about a package called dbt-expectations. And sort of the subtext here, the subtitle is extending dbt test, really, and just how a test works, and maybe a little bit also how packages work in dbt. I think they're something that people are getting excited about, and we're starting to see some really cool stuff. But it's a little bit new maybe for some of you. My name is Claus Herther. I do data analytics consulting at a little shop called Calogica. You can find me there if you have any questions. First I want to talk about is what is dbt-expectations. Fundamentally, it's a dbt package. It's got over 50 pre-built dbt schema tests. They can be applied to models or columns within your models. I typically call it a port-ish of the Great Expectations library. The Great Expectations package is written in Python. And I've been always interested in porting that over to SQL, very similar to sort of the notion that James had, that a lot of these things that we do in Python sort of by default really can be expressed in SQL. And I'm a big fan of that. It seems like the Slack channel is a big SQL fan club there, which is great to see. And it's made a resurgence really. And I think, especially with the power of Ginger, there's so much cool stuff we can do. And so this was a little bit of a dare of, can I do that? And it turns out it wasn't that big of a deal, at least to get going. dbt-expectations and Great Expectations uses the semantic of an expectation to express really what you might think of as an assertion. Here's an example. This is a YAML file that you might be familiar with, sort of similar to what you have. You have a model, and I have an expectation here, or a test that I'm applying to this whole model, that I'm expecting my row count to be between 2 values. And so these are applied just like any other test that you're hopefully already doing. The API here, I'm trying to stay fairly close to the original Great Expectations API. There's a link here in the slides that I'll post later to the glossary, which is sort of, there's a screenshot here on the right. And it really just sort of went one by one through that, because I wanted to see, if this can be done. I think the idea is that I'm expecting this to be extensible beyond the original API. I've talked to the Great Expectations folks, and they're a great team, and we've talked about how do we keep these things in sync. And I think it's a good idea to keep these somewhat in sync, but I think I wouldn't be offended if we added expectations in here that are not in the original Python package, and vice versa, because the idea here really is that this is an extensible testing package. And it's more also a demo of what you can do with dbt. I don't know that this needs to be the best testing package, but it's an idea that, or it's a project that people can use as a source of ideas for what you can do. And you might ask, why bother with that? There's already a Python package for it. What's the point of that? And in consulting, I've been getting pinged by various clients over the years that would read about Great Expectations and say, hey, this is a really cool package, we should use it. And my first reaction always is, yes, great package. I think there's really good design behind it, but we're trying to implement dbt, and what we're really trying to do is just test, right? That's really what we're trying to do. And expectations are really almost the same thing as asserts or tests. And I'm sure the computer scientists among you are going to correct me there, but I'm going to make a simplifying assumption here that those things are really the same thing. And dbt already has dbt tests. Testing is native to dbt. And we talk about it a lot. I'm not sure that people do it enough. I'm a big fan of it. It's one of the biggest selling features for me, one of the powers there. And so why not just do it in dbt? My opinion is that really most things in practical terms that you are going to want to test, you can express in SQL, just like most of your business logic can be expressed in SQL. And you're already doing this, hopefully, as part of your development workflow. And so I really like the idea that you have something like that that's built into how you already work. Really, the other big argument is that if we're using a dbt package, that requires no Python. James mentioned this. That is something that we really need to highlight, is that if you're already working in a SQL workflow, let's try to stay within that, because it's so scalable. If you can do all of these things within your Snowflake box, within your BigQuery instance, then the more power you have. And you don't have to introduce additional workflow steps. The other neat thing is that it'll work in dbt Cloud. That's one of the biggest arguments there. I know that the Fishdown folks get a lot of requests to run Python in dbt Cloud and various other things, and maybe that's even coming, who knows. But it would be really nice to just be able to run that without a lot of extra hoops in dbt Cloud. And like I said, I think it accomplishes about 90% of what Python would do for you in that instance. When would you not use this package? There are really good reasons for when you should use the original Python library, if that's what you want to do. Fundamentally, if you already have a Python-based workflow, especially data science-based workflow, maybe your data isn't in a database, it comes to you via CSV, or maybe you're not using James' package to do feature extraction engineering, you're using scikit-learn, and so you're already in the Python workflow, and then you want to express some expectations on top of this data, then you should probably use that package, because that's what it was designed for, the original Python package library, and it's great for that. There are some expectations that you might not be able to express in SQL. They have some really sophisticated, more distributional expectations in the Python package that are really tricky to do in SQL for now, and maybe we'll get there. I haven't spent that much time on that aspect of it, but there's some things you might not be able to do. So for the extra 5–10% in those cases, obviously you want to stick with that. How does the whole thing work? It's on the dbt hub, which is great. So if you want to use it, you need to include it in your packages YAML file, like so. We're currently on 0.24, which is my random version numbering schema. Latest version you can always find there. I showed an example. Here's another example. You can apply this to both models. Some tests work for models, and the name typically gives it away. Some tests only apply to columns. And I already see that I have my YAML misformatted there. That always bites me, but you'll figure it out. But some tests you apply to the table model or view model, and some to the columns. The fundamental to the whole thing, and this is really sort of why I did this, because I would always think about these things saying, hey, wait a minute, all this is really is an expression that we're trying to evaluate, right? And dbt utilities already has a macro in there called expression is true. I adapted this a little bit for a dbt expectations package, but I think for most of these expectations, all I'm doing is saying, hey, here's an expression, go see if it's true. There's some, you can have a row condition added to it, but fundamentally, I would say if you look through the GitHub repo, most of these look like that. And so I'm not trying to diminish the value of the Python package because I think there's a lot of sophisticated stuff going on there. But from a SQL perspective, the flexibility here to generate expressions like that in text dynamically is really powerful. And then just to pass that to a macro like that is pretty cool, and it keeps the code pretty lean. And so if you ever want to contribute something to that and you want to add a new expectation, for the most part, this is what it is. For example, if you take a look at the expression is true macro in dbt utilities, you'll see that even that is not a ton of code. And so you can see how you can actually quite easily do this on your own, even if you weren't using either of those packages. We're taking some data that may or may not meet an initial condition, some sort of filter. We're checking if it meets, we're checking for rows that do not meet that expression. And then we return the count of those errors as errors. And most tests that you might want to write have this sort of format here. And so you might be using some of the built-in tests today, like uniqueness and not null. And I encourage you to look at the code of those in the dbt repo because they're really clean, and it sort of gives you an idea of how to do this on your own. And so, what do you mean? You can write your own schema test? Yes, you can, and you should. Each schema test can be done as a macro. There is an older way to do data tests that still works, but for the most part, you really ought to be writing new tests as macros. And anything that you can express like that, you can make your own test. So I have an example here for some custom validator that you might want to write. And you can sort of imagine how sophisticated that can get if you really think about your particular business problem that you might have. And there you go, you just wrote a test. And you apply that just like that, just like the test from any package, you can apply your local test that you wrote. And some of you probably already do that. You could also express the same thing that I just wrote there in more verbose SQL using the expression is true macro. Cool. So what's a dbt package? We've been talking about packages. James talked about package. I talk about packages. What does that mean? You're using them today. What is behind that? And so fundamentally, a dbt package is just a separate dbt project that contains models or macros typically that you want to share or that somebody wanted to share. You, like we showed earlier, you import it via packages.yaml. Often they're on the dbt hub. So how do you go about creating your own package? That might be something you might want to do internally, or maybe something that you want to share with other people in an open source manner. Like I said, you go about it by creating a separate project. You put in there your models or macros you'd like to share. The 5trend folks have done a really great job doing a whole lot of packages for various of their connectors, and so they mostly share models. Packages like dbt-expectations are typically, my package is mostly full of test macros. So it depends on the kind of package that you might want to do. Sometimes it's both. You want to go and publish that on dbt hub. Claire and the whole Fishdown team will help you do that. That is a really neat thing because it allows versioning in much easier ways than if you did this on your own, and then you profit. Just kidding. There's no profit. This is all free, please. The last thing that I want to leave here is, because we're talking about testing so much, you do want to test your packages. And that's something that I'm starting to get maybe a little bit better about, but just putting in macros and hoping that they work, and maybe they worked when you were testing this locally, might not be enough if this is something you're going to release to the general public. And so I encourage you to really test your packages. And it's something that the dbt utilities package is a really good template for that. I literally borrowed / stole from that. And I think that is becoming a little bit of the norm of how integration testing is done. The first step in that, excellent, I see that, okay, we have an Apache license, very nice, thank you. The first step is in there, and sort of the convention, I think, is that you create yet another project within the package project called integration tests. And in there, you import the package that you're trying to test. I'm not trying to get that confused, but so in your integration test packages, packages.yaml, you import the parent package, if you will, by just doing a local import. That's something that may not be that obvious. And so the macros or the models you're trying to test in your integration test are automatically then imported, you reference them that way. And then what you want to do is, depending on the type of package you have, you might want to write some test models that use the macros that you've written and then test those. And so I have an example here of the dbt utilities package where they're testing whether the concat macro works, whether the current timestamp macro works. And there's some data models in there that have test data in there that we're trying to test. In other cases, it might be that you have, like in dbt-expectations package, I need to create some test models and schema files that use the test macros from dbt-expectations to see if they're working. It's a little bit different, but similar to the other approach. And I know this can be a little bit confusing. And if you're If you're confused, that's okay. And that's what the chat room's for, and that's what the community's for, to work that out together. Like I said, I've asked a bunch of people and borrowed from other people's work, and that is really, really fun way to learn. And then you do want to make sure that you try this on as many platforms as possible. It's always a little bit tricky when you're sort of doing this on your own and maybe you only have access to one platform, but maybe you start out supporting it maybe on BigQuery because it's fairly easy to set up a new BigQuery instance, maybe some Postgres locally, but maybe you don't have a Snowflake instance. And so that's something where maybe the community comes together and people that have access to other platforms are able to test it then. But it's up to you what you want to support, but there are really good ways to make this a little bit more platform agnostic. I always try to use a lot of these, I still call them adaptive macros, I'm not sure if that's the right term still, but adaptive macros from within dbt utilities or macros I wrote on my own that try to adapt the code to the target platform that we're on. Just makes your life easier as you extend these things so that you're not having to rewrite it later. And so even simple things like dates, date functionality is always super tricky. And then obviously the last thing is to make sure that you test pass before you submit a PR or you commit something to main. We want to make sure that when people use these things out in production, that we don't have some silent bugs in there. And then lastly, how can you contribute? This is an open source project after all. Easiest thing is to file an issue. I'm linking here to the GitHub issue tracker. And lastly, submit a PR. PRs are relatively cheap. There's nothing you can break. If you have an idea for something, that's a really good way to, because it's fairly small and easy code base, to submit a PR and then have a discussion there. It doesn't need to be perfect the first time around. I think we're all learning how to work these things, but it's a good way to get involved there. And then lastly, one of the great things about open source is that people can always also help improve the documentation. That's a really good contribution. Doesn't need to be code, but improving the docs is always super welcome. And if you have any questions, you can reach me here. It's just Claus at calogica.com. And you can always find me at dbt Slack channel as well. Thank you.
Claus, again, an incredible package, incredible presentation. Thank you so much for sharing the code and also sharing your presentation today. I'm curious, how long did it take you to build the package?
The initial was maybe a couple of days. You futz around a little bit. I had this package just called dbt test. That was the initial version of it. It wasn't using the great expectations sort of metaphor. And then I rewrote it, and so that took a little bit. But as I've pointed out to you and other people, the platform makes that really easy. I mean, it's great work. Once you're used to sort of what you're supposed to be doing with test macros, you can be really productive. And so I want this to be something that people take as inspiration to just write their own tests as well.
Yeah, for sure. I think, I teach dbt-learn, and a lot of people are so surprised at if you know what a macro is and you can go look at someone else's test, you can put those two pieces together and build your own schema test. So it's really cool. I am, for one, I'm just super excited to see some of these other packages popping up. And there's a package about artifacts and some other tooling around the ecosystem. I think both of you are pretty plugged in to the ecosystem. Is there anything that you've seen tooling wise recently, apart from your own packages, that you recommend people check out?
You mentioned earlier this pre-commit package that I've seen mentioned, and that is super cool. I know there's a whole bunch of other people working on similar things, and that's really exciting. There's almost too many cool things to try out right now.
Definitely. James, have you seen anything recently that sort of caught your eye?
Only dbt-expectations, which I think we're pretty well up to speed on now, but that was the last one that I kind of went, ooh, and jumped in and had a good experiment with. But I've just noticed the sheer volume of just model packages coming out now is huge. Like, I feel like someone every day posts a new cloud app kind of model pre-pack, which is cool.
Yeah, I'm seeing some really cool stuff from, I don't know if I can give this away, but as a partner in the space who's creating packages for one customer at a time, which I think is just they have information about their customers' data, and so they're creating a package of sources for their customers. It's just cool to see these upstream and downstream packages all coming together in the one ecosystem. Cool. Well, I think we're just going to close up early. Does that sound good to the
Were there any
person
questions
early
in the Slack that I might have missed? There's a bunch going on.
I think we were answering them as we went, but overall, we'll, if anyone has any extra questions, we'll sort of be hanging out there. So we can jump back in. But yeah, and also Claus has another package, dbt-date, which is that?
Yeah. It's just a collection of code macros because I'm always getting confused what platform supports what. And so yeah, there's another one that would be great if people contribute because everybody has different experiences on various platforms, and so that stuff gets real tricky.
Yeah, one thing we've definitely learned with utils is that we tried to cover too many use cases with it. We have date functionality and how to get column values back and some custom schema tests, and it's been actually pretty difficult to maintain. And so I really like this idea of being much more specific and focused with the different packages, and having sort of isolation of different functionalities. I think a really good pattern, if anyone is thinking about building a package, that's a pattern that I would encourage you towards. And if you are thinking of building a package, I think if you hang on the package releases channel, is probably the closest one that we have, and you want to run an idea by us, I would love to let you know if we've got any feedback on how you can make that package in the best way possible. It's something that we're definitely here to help out with.